Welcome to Ms. Cruz's video tutorial on triangle congruency proofs. If you take a look at this proof, this is located on page 15 of your triangle congruency packet. The first step of any proof is to state the given information. So in this proof, they give us that AB is equal in measure to AC. And they tell us BD is equal in measure to EC. And my reason is that this information is given to us. Now, we're trying to prove that angle B is congruent to angle C. So quickly, if I highlight this, I'll draw it in purple. We're trying to prove that these two angles are congruent to one another. So the first thing I'm going to do is mark my diagrams. They tell me that AB is equal in measure to AC. So I'm going to find the line segment AB. I'll highlight it in one color. They're telling us that that is equal to the measure of AC. So I'm going to highlight that in another color. They also tell us that BD, which is this section here, is equal in measure to EC, which is this section here. Now, looking at this proof, I see two triangles that are overlapping. So to help us better visualize what corresponding parts we are considering, we're going to create two separate triangles to help visualize these relationships. So just go to the side and create two triangles the best that you can. So the two of them may look something like this. So the triangle over here, we can call this B, A, B. And the triangle over here, we can call this D, A, and C. And I'm going to mark the point on the side AB where D lies. I'm going to mark the point over here where E lies. Because remember, they told us that these whole segments are equal in measure. And they also told us that these little portions are equal in measure. So if I take a look at these two triangles, and if I see that the entire yellow parts of the triangle are equal in measure, and the smaller parts that I have blue hash marks are equal in measure, then if I would take the entire thing and subtract the smaller section that I know, I can also say that AD and AE are also equal in measure. So to write that in a statement, reason, proof, you have to go through each step that we just discussed. So you would tell me that the entire length of AB, and then subtract the length of BD, and if I took the entire length of AB and I subtracted the little section of BD, in the end, what that's going to tell us about is the remaining section, which I have in green, which is AD. So let's compare that to the other triangle. So now we'll take the entire yellow section of the other triangle, which is AC, and then subtract the smaller section on that triangle, which is EC. And let's put that all together with what we're trying to say. And what we're trying to say is that those two green sections, the length of AD and the length of AE are equal in measure. And the reason why we can say this is because of the subtraction postulate. Now, we just said that AD is equal in measure to AE. So if we take a look at these two separate triangles, AE is here and AD is here. So now what we have, and if I were to go through, because we have the hash marks going, let me write that quickly. We're going to go through and simplify it a little bit. So we have DA and this is C. So if we were to look at these, I know that this and this are congruent to one another. We just went through with the subtraction postulate to say that AE is equal to AD. And now if you take a look at these two triangles, or if you take a look at the original problem, you have to ask yourself, do these triangles have anything in common? Do they share anything? If you look closely, you're going to notice that there's an angle A here and there's an angle A here, which the angle A also exists up here. In order to highlight this idea of sharing, we're going to say that angle A in the first triangle is going to be congruent to angle A in the second triangle. And the reason for that is because of the reflexive property. So, we're getting close to the end. Our next step, if we take a look at these two triangles, we have to ask ourselves, do we have enough information to prove that these two triangles are congruent? Now, if we take a look at these triangles, I'm going to start with the yellow. I notice that I have a side, I have an inclusive angle, and then I have another side. So I can now state that these triangles are congruent. So triangle, let's do ABE, is congruent to triangle. Let's do ACD. And that is because of side, angle, side. And now we're ready for our last step, which says to prove that angle B is congruent to angle C. Once you prove that triangles are congruent, then you can conclude that any corresponding part is also going to be congruent. So we can say that angle B is congruent to angle C because of CPCTC, which stands for corresponding parts of congruent triangles are congruent. So you can go through and you can say angle B is congruent to angle C. And if I wanted to extend this further, you can tell me that angle E is congruent to angle D because of CPCTC. You could tell me that DE is congruent to DC because of CPCTC. Once you prove that triangles are congruent, any pair of corresponding sides you can also tell me are congruent. Okay, so that's the end of this proof. Check back for some more.